in the second part of the prac, what we've again got is we've got our laser, and it's again pointing straight along this tape measure at a wall, which hasn't gone anywhere either. Now this time, instead of sending that laser light through a diffraction grating, what we instead want to do is to send it through a pair of double slits. Now we've got 12 pairs of double slits that have been scratched onto this card, and you might be able to see them if we hold it up like this, sort of tilt it that way. So these double slits through the camera, they appear to be just vertical lines, but they're actually pairs of double slits that are very, very close together. So we're having trouble telling the difference between a single vertical line and a pair of double slits. Now in the lab notes, these double slits are referred to as pair A, which is up in the top left corner, through to pair L, which is down in the bottom right corner. And what we want to do is to send the laser light through just one of these pairs of double slits. So I don't know, how about F? Let's go with pair F, and we can put these double slits any distance that we want away from the wall, but let's just go for, say, 1 meter. So again, we've got some blue tack on the back of this card to try and hold it into position. And we'd like just to arrange it so they're as vertical as possible. I think that should do the trick. And we're just going to have to be a bit careful that the laser is in fact going through the slits, because they are very close together. Okay, that seems to do the trick. And then what we expect to have happen is that over here on this wall, we expect there to be a double slit diffraction pattern, which there appears to be, because what we can see there is a whole bunch of bright bands and a whole bunch of dark bands. And these bright bands and dark bands seem to be pretty much evenly spaced, which is what we might expect, because the double slits are a long way away from the wall, at least relative to the separation of those slits, which we said was pretty tiny. Now what we're told to do is to measure the distance between the left edge of one of these bright bands and the left edge of a bright band that is 10 bands away. So to do that, let's take this handy dandy ruler again and try to align its 0 marking with the left edge of one of the bands. Something like that. And then try to align the ruler so it's parallel with the pattern. Seems to be like that. So I think what I've done there seems to be that I've aligned the 0 marking with the left edge of this bright band there. So now let's count 10 bands across. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we arrive over here, and the left edge of this bright band, which is 10 bands away, seems to be pretty much aligned with the 20mm marking. So it looks like the left edge of this bright band is about 2 centimeters away from the left edge of this bright band. So what we want to do is to use that information to figure out the separation of the centers of the bright bands, and then use that to figure out what is the separation of the double slits over here. So we'll also need to use the wavelength of the light that we figured out in parts A, B, and C. Now there's one last thing that we should take into account, and that is that the height above the table where this laser hits the double slits is not the same as the height above the table of the diffraction pattern. So that's going to affect the distance that the light travels in order to reach this wall. So we should just take that into account and measure those two heights. So let's try to measure the height of this diffraction pattern above the table. So I'll put the 0 marking so it's at the height of the tape measure, and then try to put the ruler vertically. So let's go back here because we might be able to see it more clearly. Okay. that looks fairly vertical. Okay, so now if we bring our diffraction pattern back, it looks as though it is appearing about 7.5 centimeters above the center of the table, or maybe somewhere between 7.5 and 7.6. Now the other thing that we should note is what is the height of the laser where it hits the double slits. So let's just measure that. So it looks to me like it's about at the 1.4 centimeter marking of the ruler. Now the end of the ruler, which is against the table, is actually about 0.5 centimeter away from the 0 marking. So it's probably, I would say the laser is about 1.9 centimeters above the table at the point where it hits those double slits. And so we can use those two numbers to figure out what is the distance that the laser travels in, or what is the distance between the central bright band and the double slits over here.